All right, so this will be an example of how to work with velocity versus time graphs. So please assume that these lines are all straight lines, there's no curves, and everything works out all nice and perfect, which is close, I tried. We have different time intervals. These are gonna go by 1 second. So we have an 8-second time interval here. We have some velocities ranging from -3 to +3 for our possible values. I didn't create a wide range for this. Oh, it's okay. So there's different things that they might ask you to do. They might ask you to describe in words what is happening to the object. They might ask you to find the displacement at different points in time. Draw an acceleration versus time graph. Draw a velocity versus time graph, a position versus time graph. So the first thing I want to do is I just want to kind of use this graph to describe what's going on. And you need to break things down in time intervals and be very specific. When you're asked to describe the motion of an object, when you describe the motion, you need to consider the position, velocity, and kind of the acceleration. So those are the things you need to kind of think about when you're describing. So if I was to describe this, I would say starting at 0 seconds, the object is moving to the right or in the positive x direction at a constant speed of 2 meters per second until it reaches 2 seconds. So this represents a constant speed of +2 meters per second. I would say that at 2 seconds, the object continues in the positive direction because these are positive velocities, but it slows down until it reaches a speed of 0 meters per second at 3 seconds. So it's moving from 0 to 3 seconds in the positive direction. It's at a constant speed until 2 seconds. From 2 seconds, it decreases from a +2 meters per second to 0 at 3 seconds. And it has a constant acceleration while it does that. So we actually have a constant negative acceleration there. Now, if you notice, the slope of this line actually continues to 4 seconds. So that constant acceleration is there from the interval from 2 to 4 seconds. But here in this section, because we have a positive velocity and a negative acceleration, we're slowing down on this interval. From 3 to 4 seconds, you're actually going to speed up because we have a negative velocity and still have that negative acceleration. So we're going to speed up from 3 to 4 seconds, and we're going to get to a velocity of -2 meters per second. So that means from 3 to 4 seconds, I'm going to be moving to the left or in the opposite direction I was before, starting at 0 meters per second and getting faster to a final speed of 2 meters per second towards the left at 4 seconds. Then from 4 to 6 seconds, it's going to move at that constant negative velocity of 2 meters per second until 6 seconds. At 6 seconds, we are going to have a constant positive acceleration. So now we have a positive acceleration, but our velocities are still negative. So we're going to slow down and we come to rest at 7 seconds, and we're going to remain at rest until 8 seconds. So there we're kind of describing all the different things that's going on. So there's different things they could ask us to find. For example, they could ask us to draw corresponding graphs. So for example, if I wanted to draw an acceleration versus time graph for this, in meters per second squared, and time, I should make that time go all the way to time in seconds. How would I do this? Well, acceleration is the slope of this graph, so I'd have to find the acceleration on the different intervals. Well, for this first interval here, the acceleration is 0 because there's no slope. And then if I wanted to find the acceleration for the next interval, from 2 to 4 seconds, that acceleration would be the slope of this line. So I could do, let's see, so there's a vertical change of -4 meters per second in a time interval of 2 seconds. So that's an acceleration of -2 meters per second squared. And then here we have an acceleration equal to 0. And then for this section, we go an acceleration of +9 we have a speed change of 2 meters per second, and that takes place in only 1 second. So that is an acceleration of positive 2 meters per second squared. And then here we go back to having an acceleration equals 0 for the last second. So if I wanted to draw that on my graph, I would need to make sure I try and approximate those time intervals. So 1, 2, 3, 4, 5, 6, 7, 8. And then because my acceleration is kind of binary, I can just put a positive 2 and a negative 2 there for my values. I don't need to break it down further, although I could do 1, positive 1, and a negative 1. And then I just have to graph it. So I'm a equals 0 from 0 to 2. And then I have a jump. It jumps from being 0 to being a negative 2 meters per second squared. So I show that vertical discontinuity, and that's until 4 seconds. And then we have, it jumps back to being 0 until 7 seconds. Oh, until 6 seconds. 6 seconds is when it stops. And then I jump to a positive 2 meters per second for 1 second, and then I drop back down to 0. So that would be my acceleration versus time graph. So it's just kind of showing that I have uniform acceleration on different intervals, and it changes instantaneously at different spots. So then the other thing it could ask us to do is it could ask us to draw a position versus time graph. And that is a lot trickier. So actually, I'm going to draw that over here so I can get it to line up, and I have room to work. So x in meters, 0, 1, 7, 8. All right, so how do we find my position? Well, I can find my position based on the area under the curve, because the area under my curve is displacement. Now, here's the trick. They didn't tell me where I started. So I can start at any position. I can't tell what my starting position is from this graph. So I'm just going to assume, for my purposes, that my x0 is equal to 0. So I'm going to start here at the origin. But basically what happens is if my initial position isn't 0, it shifts this graph up and down. So if I had started off at a positive, x value, it would shift the graph up and down. It would not change the shape. My starting position only changes that y-intercept on the graph. It doesn't change the shape. So if I look on this first interval right here, I have a constant velocity. Well, how does a constant velocity show up on a position time graph? A constant velocity would be a straight line where the slope of that line is equal to the velocity. So that means that I need to draw a straight line from 0 to 2 seconds that represents my velocity. So this slope would need to be a positive 2 meters per second. Well, how do I figure out how far I went? What's this y coordinate here? Well, the area under the curve is my displacement. So from 0 to 2 seconds, I go 2 times 2 meters. So that's 4. So actually that's going to be a 4 meters right here. So at 2 seconds, I am at 4 meters. Now what's going to happen is for this section right here, from 2 to 3 seconds, I'm still moving in the positive direction. But what happens, 2, 6. But what happens is I'm slowing down. Well, how does slowing down look like on a position time graph? Well, slowing down means a flattening of my curve until I have no slope at 3 seconds. So if I know that that shape is going to be something kind of like that. So it's going to curve to a flat. My slope is going to change gradually kind of back towards a slope of 0. Well, how far do I travel? Well, this is a triangle, so if I area of this triangle, it's going to be 1/2 base, which is 1. My height is 2, so half of 2 is 1, so I'm only going to go to about 5 meters here. So at 3 seconds, I need to be at 5 meters. So that's going to be something kind of like that. Nice kind of smooth curve there. When you're drawing these, try not to do sketches like this. You need to have a smooth curve. It's best to do these in pencil or something that you can erase and adjust as you go. So I'm going to have this smooth curve from 2 to 3 seconds. And then from 3 to 4 seconds, I'm going to also go, since it's 1 second with the same acceleration, I'm also going to go just 1 meter. So basically from 2 seconds to 4 seconds, I'm just going to come back to where I started at 2 seconds. So that's going to be just a smooth curve. Now on this side, I'm speeding up because I have an increasing slope on this side. So you can see that that represents speeding up from here. Speeding up in the negative direction because I have a negative slope, but it's getting steeper. And I'm back to 4 meters at this point. And then for the next 2 seconds, I'm going to move at a constant speed. So in that constant speed, I'm going to have that slope of -2 meters per second. So what that tells me is that I'm going to go another 2 times 2, which is 4. So that means at a constant slope, I'm going to go from 4 to 6, something like that. I might adjust my curve over here to kind of match that. So I kind of get that smooth little transition there. So I have a constant negative slope of 2. And then what's really cool is actually at 6 seconds, because my positive area here would equal my negative area, I've actually returned to my starting position. But I don't stop there. I have this last little section. In that last little section, I have in that one, oh, it's not my last section, but from 6 to 7 seconds, in 1 second, I have a change of 2 meters. In this case, I have a negative velocity and a positive acceleration, so I'm slowing down. And that's going to be a displacement of 1 meter. So at about -1, that's 7 seconds. So I have to be getting shallower. So I'm kind of showing a curve getting shallower there. And then from 7 to 8 seconds, I have no motion. I have no velocity, I have no acceleration, so that is just a horizontal line. So I have constant velocity to this point. I have constant velocity on this interval, and I have constant 0 velocity on this last. So constant velocity equals -2 meters per second. So it's going to be a positive 2 meters per second. And then for this curved section right here represents slowing down and then speeding up on that interval right there. And that section right here has a constant acceleration of, what did we determine that acceleration was? For that interval, -2 meters per second squared. For that. Oh, wait, I did my math wrong. Half of 2, 1, oh wait, no. Yeah, my acceleration is +2 meters per second squared. Okay, so the acceleration here in this section, which represents slowing again, has a constant acceleration of +2 meters per second. Now, from a position time graph, I can't calculate my accelerations directly without calculating my velocities. So I've found a way to find displacement at different points. I could find my area of the curve. If I wanted to find my displacement at 6 meters, I could find my displacement for this section. I could find my displacement at 3 meters. I can read values off these graphs. I can calculate speeds, positions at any point in time using that. So you'll get more practice with doing graphs like that. But I hope that helps.